All right, ladies and gents, we've already went over section 8.9, which is sign charts, when we've talked about the major distinction, which is the difference between linear inequalities and nonlinear inequalities. And linear inequalities look like a straight line form, mx plus b. It's degree 1. So if they're in linear inequalities, then we talked about why there seems to be a simplistic way of doing it, but that way is only for linear inequalities. Everybody else, if anything, you could erase the linear inequalities and just change your method to making a sign chart. And you'll always get the right answer, okay? We talked about it before. In order to make a sign chart from the last video, okay, the first thing you need to do is make sure you have 0 on the right side of your inequality. And caution, do not clear the fractions in inequality, because we don't know whether or not that denominator now is negative or positive, so we don't know whether or not to flip the sign, okay? So those are all valuable things that we're talking about right now. So once you've already not cleared the fraction, okay, and you basically kept the same, if there's a number over on the right side or an expression or something, subtract it over, simplify it down, get one complete expression, and then find your zeros and undefines, and then finally make your sign chart. Okay, so that's the general process, but we're going to go through a couple examples that outlines that in big detail, okay? So here we go, let's get started. So number 1, okay, it's just going to say solve. Okay, now note it's the same thing as like an equation, right? But you have to make note to yourself that it looks like an inequality. So I'm going to give you one that looks a lot like something from yesterday, okay? So let's say what we are trying to solve is x squared minus x minus 2 over x plus 4 greater than or equal to 0, okay? Note there was already 0 on the right-hand side, so that's a good thing. Okay, so checkpoint 1, I'll make a little list here of things I need to be conscious of. Okay, note. So caution. I guess that we'll make a caution box here. So caution. Okay, make sure these two things do not happen. Okay, because if they happen, game over, you lose. Okay, 1, do not clear fractions. Clear fractions. Why? Because in undefined, if I were to multiply both sides by, let's say, x plus 4, and this is what you decide you wanted to do, yeah, if it's an equation, 100% legal. But because it's an expression, because it's an inequality, we have a huge problem, because is x plus 4 negative or positive? And that's the point. Okay, we don't know, because it's depending on what x is, so we don't know whether or not to flip that sign. So we needed new methods in order to handle this. Okay, so something very big to keep in mind, and don't fall for any boo-boos here. Let me see, will it let me go back? It will not. All right, so I'm going to erase this stuff out. Boom, 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 boom. Don't need that. All right, so don't clear fractions. Number 2, okay, once you do that, you don't want to clear fractions. 0 must be on other side of inequality. Because in the pretense of making a sign chart means all we have to look at is the sign, which is positives or negatives, like we did in the last example. Okay, so I want to make sure 0 is there. Okay, so these are setting up for later. All right, so next thing you want to do is make sure that your function on the left-hand side is then factored. And guys, expressions are functions, okay? We just don't know what we're doing with them yet, but they are functions, all right? So I'm going to factor this thing out, and this is where I'm going to stop at. So I'm going to factor this as much as possible, if possible. If it's not, I can do it the way that it is, but I like to factor it because it makes the sign chart be easier. So that's this divided by x plus 4, okay? So again, once you have this is the first place you need to be at. So when showing your work, you should be for sure to do this one piece. Super important. Okay, so that's number 1. Number 2, okay, next thing we need to do is we need to find, so maybe number 2 and number 3, which is find out when this function here in yellow, okay, notice it's set is equal to 0. And here, we're not even considering the inequality, okay? So in your mind, okay, throw this out for the time being. Okay, and we're just going to analyze what's happening on the left-hand side. So just for the left-hand side, we need to figure out when that thing is going to be equal to 0. Okay, so set the function, that thing in yellow, equal to 0. And just so you guys are clear that it's the thing in yellow, Okay, those two are the same things. Now in 1800, if we formalize this more, we'll actually say let f of x equal the thing on the left-hand side, and then we'll do a sign chart on the thing on the left-hand side. Okay, so sign charts do more than just solve inequalities, ladies and gents. I do this once a video, I think. My thumb hits something, and it makes it all go all weird. All right, so sign charts, again, let's get back to this. Sign charts don't just solve nonlinear inequalities. They do way more than that, okay? We'll use it for graphing. We'll use it for derivative inflections, okay? We do it for a whole bunch of different things, okay, in Calc 1, Calc 2, and 1800. So the way we're going to use it now is to solve inequalities. You'll use it in a different way later. All right, so here we go. I'm going to set my function equal to 0. I need to change my pens out real quick. So setting my function equal to 0, x minus 2 over x plus 1 over x plus 4 equals 0. Welcome back to chapter 6. And you guys know how to solve this, so clear your fractions, which when you multiply both sides by x plus 4, it will vaporize. If you don't believe me, here's the work for you. I'm going to hit both sides by x plus 4. And again, why is this thing an equal sign, not an inequality? Because in order to find when it is equal to 0, I need to set it equal to 0. And that's what I'm doing here, setting it equal to 0. Clear the fraction, and now you're left with x minus 2, x plus 1, and that equals 0. And then when you solve this, just parlaying some of the work, I get these two numbers as being my zeros. Okay? Second thing you also need to gather is what makes this thing undefined. Okay, what makes this undefined? All right, and again, what makes something undefined is no different than what we hit in chapter 2 when we're talking about domain. This is what makes the denominator makes that denominator equal to 0. So quite literally, what we're going to do is we're setting it this. Okay, so we're taking the denominator out of our function that we got from step 1, and we're setting that equal to 0. So this turns into x plus 4 equals 0. And that's what this is. So now we could solve that. And again, it can't happen. So this is x cannot equal negative 4. So finally, what did we do all of this for? All of this was done for the sign chart. And note, I'm still not looking at the inequality. I crossed it out in blue. When I bring it back, I'll bring it back in blue. That way you guys can see when that inequality actually comes into play. So right now I'm just gathering the information about the function that's on the left-hand side. So the function on the left-hand side, we found out one was equal to 0, and we found out one was undefined. Now 4. We're going to make our sign chart. Now a sign chart is no different than a number line, okay guys? So we're just going to draw a number line here, and what we're going to put on here is our zeros and our undefineds, okay? And I'm going to label them to keep track of them. So this guy's an undefined, this guy is a 0, and then this guy is a 2, okay? And all we're going to do at this point, again, so I haven't looked at the inequality yet, remember I haven't brought it back in blue. Now I just need to figure out whether or not these signs are positive and negative. Now, what do we need to do in order to figure this out? Well, the function in yellow, it all pivots on this guy. It all pivots on this guy right here, all right? So you see how there's 3 parentheses there, right? There could be a number on the outside or a negative or a positive, so you have to take those into account. But bottom line is I need to figure out whether that thing is going to be negative or positive, all right? So when you plug in negative 5, we end up with a negative in the first parentheses, a negative in the second parentheses, and a negative below it. This is why it's called a sign chart, because I don't really need to know the numbers. I just need to know the sign. So a negative times a negative times a divided by a negative, well, that's going to be a positive on top divided by a negative. So therefore, that has to be the grandioso of negatives here. So that's what this guy is. Okay, and when you do this for each one, you'll see that certain things change. Okay, when you plug in negative 2, you end up with a negative, another negative, and then a positive down here, which then leads us all to a positive. After you multiply those things together, when you plug in, and the guy to always plug in when you're going from negative to positive is which number, guys? 0. Good job. All right, so you plug in 0, and we end up with a guy that looks like this, which is the first one is negative, second one is positive, third one is positive, and then that gives you a negative here. Perfect. After you multiply everything out. And then last but not least, everything is positive in parentheses when you pick something out of this category. So, I don't know, pick 10, I guess. Because you pick any number in that interval. The idea is again, it's when it's above or below the x-axis. Above is positive, below is negative. But all we need to know now is when is it positive and when it's negative. That's all we're trying to extract. Okay, so here we go. So now here they're all positive, which means everything here is positive. All right, so now that we got all this going, okay, we still haven't looked at the inequality yet. The inequality is in blue, okay? Finally, once we get here, step 5 finally comes into play. And step 5 is actually when we take a look at the inequality, okay? So what is the inequality finally asking us? Now maybe this is I need to have this expression down here, so I'm going to copy this if you guys don't mind. I'm going to paste her right here. All right, so now, going back to this, now I'm finally looking at this. So, oh goodness. So, since I'm trying to look for, and this is the big point here, so you could do this in your head, or you could put it down on paper, but all that we're going to do at this step is extract the answer from the sign chart. So now I'm looking at when this thing is greater than or equal to 0. To be greater than 0 means you're positive. To be equal to 0 means that we keep our zeros. Okay, and we did an example yesterday where it wasn't equal, and then we threw out the zeros. But here's one thing that's for sure. Your undefineds will always be thrown out because they're undefined. We can never have undefined things, no matter what the topic is. Okay, next, because it says equal to 0, the second line down here, I'm going to shade in these and make them equal to. If it was strictly greater than, they would also be open circles on these because I cannot include them. Okay, so we'll talk about that in a second. We'll change this guy around. Okay, and then finally, here we go. We want when it's greater than. Well, greater than are what kind of numbers? Positive or negative numbers. Greater than 0 is for sure positive numbers. So my answers are going to be these guys in blue. Whoops. So positives and positives again. So that's my answer. So literally, we look at the first step to analyze which answer I want. Since I want greater than or equal to 0, I'm looking for when it's positive or when it's equal to 0. Okay, so for this expression, the x values that satisfy it, all right, are the ones that are from -4, not including, to -1. But that's going to be a hard bracket, not a soft bracket, because it's going to be including -1, union 2 to infinity. So those are all the numbers that have, those are all the x values that make that initial expression greater than or equal to 0. That simple. Okay, so bottom line is, do a quick overview just so you guys can see. Okay, I'm going to write a little bit on this. From the original problem, subtract things over if there isn't a 0 over there, and caution, you can't clear fractions, and a 0 must be on the right-hand side. Okay, so we pull it all over. Here we started with that, so that's cool. Okay, we had to find, so some side work. We got to find when that thing in yellow is 0, and find out when that thing in yellow it can be undefined. Hence, we said it's denominator equal to 0, and we solve both of those to get those numbers out. Okay, note they're equations, not inequalities. All right, so now we put those things in and we test each interval. Where do we test it? Back into the yellow function. So it really comes down to your ability to factor things really clearly. So we test things in those functions and we figure out whether or not they're positive or negative, okay? Whether you look at the signs like I did or you look at the actual physical number, that is up to you, okay? Bottom line is you should end up with the exact same number. So it might end up being -5, the bottom for this region. Bottom line is that means that side's negative, okay? Then now finally once we've created our sign chart, step 5, we just need to answer the question. So we're looking for when it's greater than or equal to, right? Because it's greater than, that means I'm looking for when it's positive, hence why I shaded in here to here and there to there. And then because it's equal to, that's why I kept this and this. Okay, so therefore, but we could not have undefined at any point in time, and we shaded in all of our positive stuff, the green positive. So therefore, that's why this is our answer. Easy peasy, okay? So that was one example. We had a quick overview in 15 minutes, and the next 2 examples will go quicker. As a matter of fact, what I want you to do to get some practice in, I want you to pause the video, try it, and then come back and see if your work matches mine, okay? Same kind of idea, all right? So remember all the things, don't clear fractions, and you must have 0 in the inequality. So I'm going to do the same guy, except now, let's get some scrap paper. But you still have those 5 steps. You should have everything subtracted over, no inequalities clear, that's first step, and it all smushed together and nice and factored. Second thing, zeros undefined. Third thing, sign chart. Fourth thing, give me the answer, okay? So here we go. So here's an example. This one actually came from fall 2008's final exam. So it was 2x plus 1 over x plus 1 is less than or equal to 6. Okay? Note, We don't have a denominator, so that's good. Sometimes we won't have one, cool. But then now, notice not equal to 0. So first things first, I got to do some prep work. I'm going to have to subtract it over because I need a 0 over there. Done and done. All right, now let's multiply this out and see if we can get this refactored. If not, then we have to do some quadratic formula stuff. Okay, so let's just make sure. So I got 2x squared plus 3x after you distribute everything out. Let me show everything. Okay, but here's the thing, guys. If you expect me to show everything for you so you can see it, you're not building critical thinking skills. You should already be able to see where things came from. That's how you grow your skills. Okay, plus 1 minus 6 is less than or equal to 0. And then 2x squared plus 3x minus 5 is less than or equal to 0. Now, here's the thing. If you don't know how to factor things with coefficients of 2 in the front, this is going to be a problem. Okay, so your coefficient game has got to be good. So I can tell you that this is going to factor into 2x and x. I'm thinking plus 5 minus 1. Okay, and guess and check. 5x negative 2. If yes, that's right. Okay, so now we're right here. So this is where I want to be at, and this is now my function. This is the function I'm going to do everything on. Why? Note, I didn't clear the denominators, and 0 is not on the left side. Note, I'm looking for when it's less than or equal to 0 at the end. Okay, so keep this in mind. But for right now, I don't care about this. So just get rid of it. Okay, two things I need to find, and it should be like clockwork. I need to find the zeros. So once you're here, and we're looking for that, guys. So make sure you have that. I'm looking for the zeros, and I'm looking for the undefineds. Okay, what makes something a 0 is by setting the thing in yellow, the function equal to 0, and then solving it. What makes something undefined is when the denominator can't be equal to 0. The same thing as the domain restrictions from the past. Okay, guys. So here we go. And just so you understand what came from where, the function is the thing in yellow. So the thing that we isolated for. The denominator, clearly there's none here, so there's not going to be any. Okay, but that's where you're going to be getting those pieces of information from, is the work in yellow. Okay, so now we end up with 2x plus 5, x minus 1, that can equal 0. So 2x plus 5 equals 0, x minus 1 equals 0. So by pushing everything over, I just want to make a comment about this. It makes it way easier just to do the solving part. Because imagine if we didn't do that earlier, we'd be struggling to solve right now. So this gives me x equals negative 5 over 2. And it gives me x equals 1. All right, let's try to find our undefineds. Well, that's a denominator. Well, the denominator here, technically the denominator is 0. It's not 0, it's 1, right? Because if there's nothing down there, we assume that it's 1, right? Like 2 by itself is the number 2, but that's really 2 over 1. So really this is 1 can't equal 0, which makes no sense. Hence, there is none. Okay? And you can have none. That's fine. Okay? So only got two things to worry about, but we are looking for this guy and that guy. Next, step 4. Let's make our sign chart. Okay, what goes on our sign chart? All the information from steps 2 and 3. Boom, boom, and put them in numerical order, ladies and gentlemen, and make sure you label them. Okay? All right, here we go. So it asks us to figure out the signs, and I got to plug into the original function in yellow. So I'm going to plug in a negative 1,000 in. Usually big numbers are easier for me to just know whether or not they're going to be negative or positive. So that means I have 2 parentheses I'm plugging into in the original function. If I plug in the number negative 1,000 into that function, I end up with a big old negative and another big old negative, which makes this effectively positive. Yay. Okay, again, I said I'm not looking at the inequality. I'm just figuring out whether or not they're negative or positive. I'm going to plug in 0. 0 is going to give me a positive and a negative, which effectively gives me a negative. All right, and then finally, I'm going to plug it in 1,000 here, which is going to give me 2 positive, which effectively gives me another positive. All right, so, and I need to write those in the color. I'm a big stickler for making sure things are pretty, because if they're pretty, you're going to want to look at them. And if you want to look at them, you're always going to get the right answer, or you're going to have a less chance of catching a wrong answer. So the guys with the nice handwriting tend to always have prettier work. All right. All right, so now we're here. So we've done all this work, and now we can finally give them their answer. So here's the answer. 5 is answer. Now, some people shade in their sign chart. Some people don't. So I'm going to shade mine in. And I think most people do here. I'm going to get rid of this. So now we can finally look at this. Okay, so I'm looking for when it is less than or equal to 0. So I'm going to handle equal to 0 first. Well, if it's equal to 0, that means I need to include my zeros. Done and done. Okay? Doesn't matter what it is. Okay? If that equal sign was not there, then I would not have included my zeros. Okay? It would be open circles there. Okay. And then finally, I want to be less than is less than positive or negative. Well, I want my function to be less than. Less than numbers are negative numbers. So I'm looking for the negative quadrant, the negative interval. So therefore, the answer would have to be negative 5 over 2 to 1. And check this out. Let's go one step further. Just simple sidebar. Let's say instead they had the exact same inequality. They had the exact same inequality. Right? This guy. Copy. Paste. So this is a sidebar. This is not part of this problem. The problem's technically over once we put our answer down. Okay, let's say they said the exact same thing. Okay, but instead of giving you this guy, this inequality right here, they said greater than, right? Not less than, greater than. Well, we don't have any more work to do. We've solved every inequality, so check this out. Well, we're still going to, remember, because we didn't look at the inequality to the very end, so we really just analyzed this thing on the left-hand side. We figured out it's zeros, it's undefined, and we made its sign chart. So all this information that was right here, from here to the middle, was about the guy on the left. It had nothing to do with the inequality. So the sign chart lets us solve every single inequality possible. So check this out. And I'll do this in yellow. Since I'm looking for strictly greater than, that means I'm not going to include my zeros. So I would not include my zeros. So actually, maybe I'll draw another number line here to burn this home. You'll still need to do all of the work here. You'll still need to do steps 1, 2, 3, and 4. I'm just optimizing the fact that we've already done the problem to drive a point home. So the sign chart looked like this. It was plus, minus, plus, and these are both zeros. Okay, so that's really what it was. Now, because it says greater than, that means I'm looking for when it's positive, but it's no equal to 0. So I'm not going to keep any of my zeros, but I want where it's greater than. So effectively, that's going to be my answer. So note there's no different kind of process behind this. There's only one process, except that one process gives you all the information. It's a beautiful thing. All right, so bottom line is make sure there's 0 on that left side, okay? And then you might need to put things together. Like so in this case, we had to do a whole bunch of prep work before we went into surgery, right? We had to redistribute things out and refactor them to make things easier. All right, here's one more, and I'll let the video run it out. I'm not going to talk my way through it, but I want you to pause the video at this point and try this problem, okay? It came from another final exam, okay? But I do think it is worthwhile. Okay, this guy is another one, but here we go. Actually, let's work through it. Why not? The video's up. We're already running a little longer, so I think it's worthwhile. All right, so I'm going to subtract it over. Why? Because like I cautioned you in the beginning, we need to make sure 0's on the right side. And now I'm going to add these guys together, and I hope you guys are good at finding CDs at this point. So after we find a CD, I'm going to multiply the first guy. Whoops. Again, my big paws tend to touch everything. I'm going to multiply the first guy by x plus 4 over x plus 4 and x plus 3 over x plus 3. Again, I'm not clearing the fraction. You clear the fraction. Congratulations. You will not be good at sign chart stuff because that's epically wrong. Okay? Never clear the fractions. All right, guys. Here we go. So my CD here now becomes x plus 4 times x plus 3. And then up top, I end up with x plus 4 minus x minus 3. Don't forget to distribute the negative in. These twos will drop, which gives you 1 over x plus 4 over x plus 3. Okay? So this is a guy. It's all combined. It's all factored out. There's a number up top, though. Okay? But that number is 100% positive all the time. So in our sign charts, my numerator is going to be positive all the time, okay? So no, this is number step 1. Let's find our zeros, which is step 2. And our undefineds, which is step 3. And you'll notice that these go very, very quickly. You're going to get to a point where you guys are just going to be able to pull things out of the function. So for example, you're going to say the undefineds are x equals negative 4 and x equals negative 3, right? Just by looking at it. There are no zeros. Why? Because when you set this thing equal to 0 and you clear it out, right? So when you actually do 1 over x plus 4 times x plus 3, you set that thing equal to 0. You clear it out, you have 1 equal to 0, and that makes no sense. Hence why it's none. Okay? Really, really simple. So if you notice now, I took away some of the color, and I took away where I got some of the things from. So go back and figure out. If you don't know where I got these numbers from, you need to figure it out. This is where the problem stops for you. All right, finally, number 4. Let's make our sign chart. Okay, what goes on our sign chart? Everything from number 2. So nothing comes from the, number 2. And number 3, it's -4 and -3. Now, we're going to have to plug numbers in. Yeah, plug numbers in. Okay, these aren't zeros either. These are undefined, which means I have to throw out undefined. You have to. So here we go. We're going to throw those out. But this is what I wanted to talk about, what makes this example unique. The numerator, to figure out the sign, is going to be fixed all the way across, because 1, and I'm going to get this, 1 is positive, no matter what. Okay, so they'll always be positive, but your denominator will change. Okay, this means negative, which ends up making this effectively a giant positive. This becomes positive, negative, which makes it a giant negative, and this one becomes positive, which makes it all positive. Now, the last 3 examples, caution. People will always make this assessment of, oh my God, it's going to always alternate and be plus minus. Not true. If you think it is, it's going to be a disaster. Okay, it does not always alternate, and I will say this just to drive it home. It doesn't always alternate. All right, now finally we're at step 5, which is giving them the answer. Okay, now that we have our sign chart created, and I'll highlight that in green. So I want when things are greater than 0, not equal to 0, and I can never have undefined. Well, good news is I have no zeros, and I'm getting rid of the 2 undefineds that I do have. Okay, I want to be greater than 0. Now, greater, is that positive or negative? For sure, it's positive. So your answer has got to be, negative infinity to -4 soft union -3 to infinity. Easy peasy. All right, so it's really that simple. So don't get yourself twisted on stuff. Just make sure you don't clear fractions. Make sure you subtract things over and you treat it like an expression. Get it all factored out to get the problem started. And once it's all factored out, and we're at step 1, I think my computer just had a brain fart. Maybe. Did it hurt itself? It might have hurt itself. I think it hurt itself. Nope, we're back in business. Okay, so long story short, once you get your answers, you're ready to rock and roll. All right, so here's one to try. This one will not alternate, and this will be on the quiz. I'm going to try new formatting for a quiz. So try this guy out. 2x, I want to figure out when this thing is less than 0. Okay, not equal to, less than 0, and you should end up with an answer. Okay, all right, guys. So again, in order to do some things you've never done, you're gonna have to try some things you've never tried. All right, push yourself out of your comfort zone, trim the fat, get rid of the things